Let's talk about lists and recursion, which can certainly be used together. Often, a feature of lists called a slice is used in recursive implementations. The details of a slice are going to come in a later video, but I'll show you one example. The reason we use slicing is to break up a list into its first element and the rest of the list. So, here's the syntax you need to know. For a list stored in S, the expression S brackets 1 colon close brackets is called a slice of the list, a slice from index 1 to the end, or sometimes I'll say a slice from index 1 onwards. What a slice is it's part of the list. So the value of this slice expression is a list whose length is 1 less than the length of S. It contains all of the elements of S except for the first element, S0. And slicing S doesn't actually do anything to S. So if I say S equals 2, 3, 6, 4, now S is the list with 4 elements. If I slice it, I'm getting everything except for the 2. So a list containing 3, 6, 4. S is still 2, 3, 6, 4. And so a slice is just an expression for getting the rest of the list. In a list S, the first element is S0, as we know, and the rest of the elements are S from 1 onward. This is an important view of the contents of a list because recursive functions will often make a recursive call on the rest of the list because it is a list and therefore can be processed in a similar way, but it's a simpler list because it's shorter. Here's the simplest possible example, how to sum up the elements in a list. Now, this is built into Python. You never need to write this function, but it's good practice anyway. So here's our task, implement SumList, which is a function that takes a list of numbers S and returns the sum of those numbers. If a list is empty, the sum of its elements is 0. So here's the implementation. Summing up the elements of a list S, for example, 2, 4, 1, 3, adds up to 10, has a base case where the len of S equals 0, where S is the empty list. In that case, the sum of the elements is 0. Otherwise, we return a number which is the result of an adding expression that involves a recursive call to SumList. Spend a moment to figure out what it is, and then I'll give you the recursive idea first and the code second. So here's the recursive idea in 3, 2, 1. The sum of the elements of a list is the result of adding the first element of the list to the sum of the rest of the elements of the list. The reason this is a useful recursive idea is that sum of the rest of the elements is a recursive call. With that idea, see if you can fill in the code. I'll show it to you in 3, 2, 1. The first element, S0, is a number because this is a list of numbers. And the sum of the rest of the elements you get by calling SumList on a slice of S from 1 onward, which is the rest of the elements in the list. This is a number, this is a list, but calling SumList on a list gives you a number, so we're adding 2 numbers together. In this case, we would be adding 2 to the sum of 4 plus 1 plus 3 is 8, and 2 plus 8 is 10. Okay, now let's do a more challenging problem using tree recursion. A sublist of a list S is a list with sum of the elements of S. It could have none of them, it could have all of them. Our job is to implement large, which takes a list of positive numbers S and a non-negative number N. It returns the sublist of S with the largest sum. Well, that would be the whole thing, except there's a constraint. It's the largest sum that is less than or equal to n. So we might only pick out some of the elements of S in order to make sure that their sum is less than or equal to n. And we can call SumList, which takes a list and returns the sum of its elements. I filled in most of it for you, leaving just the 2 recursive cases. So let's take a look at this. This is not necessarily the shortest or the fastest implementation, but it is one that shows you how to approach tree recursion problems using lists. So in this case, we're taking in a list 4, 2, 5, 6, 7, and calling it with various different values of n. If n is 3, then the sublist with the largest sum less than or equal to 3 is just 2. There's only one element in that sublist. To get up to 8, we do 2, 6. To get up to 19, 4, 2, 6, 7, 20, 2, 5, 6, 7. The recursive idea here is that the first element is either in the large sublist or it's not. And then once you've decided whether it's in or it's not, you have to decide what sublist of the rest of S you're going to keep as well. I'll leave it at that for you to work out the details, but first I'll walk through the code. If S is the empty list, then its only sublist is the empty list. And we're assuming here that n is non-negative, so it'll be at least 0. If S0 is greater than n, so that's the first element of S. If it's bigger than n, like in this case, 4 is larger than 3, then it sure can't be in a sublist that sums up to less than or equal to 3. And so we skip it. What do we mean by skip it? Well, we just call large on the rest of S using the same maximum sum. And since there's no sign of S0 anywhere in this expression, it will be left out of the eventual return value. So down here, we know that first is less than or equal to n. We're either going to use first or we're not going to use it. If using it gives us a bigger sum than not using it, we'll return that. Otherwise, if not using it returns a bigger sum, we'll do that. Is that possible? It is. Let's take a look at this second example. 4 is the first element. It turns out that not using 4 gets you a sum of 8, whereas using 4 would leave you with a sum of at most 6. So how do you figure that out? Well, let Recursion do it. Try it both ways. Check out which answer got you the bigger sum and return that answer. Okay, think about it for a minute. I definitely recommend pausing the video to see if you can work out these expressions, which both create lists that are sublists of S and sum to something that's less than or equal to n. And once you do that, compare it with my answer, which I'll show you in 3, 2, 1. If you're going to include S, then you need to build a long list that has the sublist of the rest of S that sums up to n minus first, and then includes that first number. Why are we subtracting first from n? Well, the answer is that once you've used a 4, you're going to sum up to 8 minus 4 with the rest of the numbers. And then you're including that 4 in the result. Now, if you don't include first, then the result is the same as the expression we wrote up here. It is a sublist of the rest of S, not including S0 or first. In this case, since we haven't included any additional numbers, we can still sum up to n. Okay, so that example should give you an idea of how to use recursion and lists together. The most common way of breaking apart a long list into parts is to think about it as its first element and the rest of the list, and use the rest of the list in a recursive call.